How we can prepare them? First, if I'm majorly, we have to discuss the preparation of nitrogen, but I have given for the other hydrides as well. As you can see, magnesium nitride on reaction with water, it gives you what? It gives you out ammonia, and the magnesium hydroxide is formed. Again, if you remember the my trick, whenever something is reacting with water, its oxidation state is going to change? No. In 99%, this is not going to change. You can check over here, the oxidation state of magnesium is what? It is +2. In the case of nitrogen, it is -3. In the magnesium hydroxide, the oxidation state of magnesium is what? Again, +2. And in case of nitrogen, it is what? -3. If it is a acid-base reaction, the oxidation states are never ever going to change unless it becomes a redox reaction. If there is a possibility water can oxidize, right? Oxygen is having -2 oxidation state, it can go and form oxygen, right? So that is why I'm saying about 99% of reaction can be done very easily. There are few in which the redox reaction is happening. Those are the ones you have to remember. Moving further, that is the preparation of ammonia. Ammonia is also prepared by what? Which kind of process? The Haber's process, right? That process is one of the most, crucial industrial reaction, right? Why? Because if you people think about it, right, you can actually check the growth of any nation on the basis of preparation of few chemicals, and those few chemicals are what? Your ammonia, your HCl, and your sulfuric acid. Why? Because if you cannot prepare ammonia, what will happen? You cannot prepare urea, right? And urea is used where? In the agriculture. If ammonia is not there, what will happen? The farmers cannot grow the any crop at a very large scale. You need ammonia, you need urea for the nutrients. That is why urea is so much important, or the present making ammonia is so much important, right? So next is let's see how does phosphine is formed. You can see when the calcium phosphide, when it reacts with water, it gives you phosphine gas. Again, as you can see, the oxidation state of phosphorus is what? -3. Oxidation state of calcium is what? +2. When they react with water, you can see what is forming? Calcium hydroxide, in which the oxidation state of calcium is what? Again, +3. In the case of phosphine, you can see what is the oxidation state of phosphorus? -3, right? Again, if you know the oxidation state, no one can stop you doing a lot of questions or a lot of reactions. Moving further, then how we can make arsenic hydride? As you can see over here, the same reaction, but you have to react it with HCl now. Zinc on reaction with your hydrochloric acid and followed by some heating, you can see zinc chloride has formed along with the arsenic hydride, right? Then magnesium bismuth, you can see over here, it is reacting again with HCl. The first two, the nitrogen and the phosphorus, they were reacting with the what? They were reacting with the water. But over here, in the case of bismuth and the case of the arsenic, you can see we have used hydrochloric acid. Right? There are another method that is by the reduction of the trihalide. On the reaction of any trihalide of the group 15 elements, right? When it reacts with lithium aluminium hydride, this is the name of this compound. It is lithium aluminium hydride. It is used as the reducing agent in the organic chemistry as well as in the inorganic chemistry. Why? Because it supplies you hydride ion. That is, when if you are giving someone hydride ion, that is you're doing the reduction. The M is your nitrogen, phosphorus, arsenic, or bismuth. Or the antimony, but not the bismuth. right? So what is the structure of trihydrides? It is a pyramidal structure. Can anyone tell me why does this question is again a very popular question? If I give you in the CBSE, they ask why PF5 exists but not PH5. Why is that? If you remember, I have explained you these things in the chemical bonding as well. The reason is simple, because in the case of fluorine, the amount of energy required to promote this electron to the, obviously there will be what? There will be my 3d orbital to promote the electron from our 3s to 3d. Some of the energy is required. This energy cannot be supplied by the hydrogen atoms, but fluorine, being a very electronegative atom, can cause the unpairing of the 3s electron and promote it to 3d. That is why your PF5 exists, but the hydrogen, which cannot do so, it cannot promote the electron from 3s to 3d. That is why the PH5 does not exist. It only PH3 exists, right? So this is the reason. As you can see, they are going to have a pyramidal shape, right? So here, any element M, it is going to be a pyramidal shape. The lone pair will be residing over the